Okay, I want to just show you an example of A star with multipath pruning that actually doesn't work if my heuristic is admissible but not consistent. So here is a graph. This is the start node. This is the goal. You can see the heuristic for all of these nodes is 0 except for node D, which has a value of 5. And so 0 is obviously less than or equal to the cost of the path for all of them. 5, if you look at the path to get to the goal, it's 1 plus 4 plus 3. So 5 is less than or equal to that. So we're good. So let's just run this and see what happens. We are going to take a find step, find the neighbors of A. It's B and D, and so we'll put them back on, and we're putting them on to the frontier in order of the F value, right? Where the F value is the cost of the value of the heuristic plus the path cost so far. So that means that our A to B path is first on the queue. I'm also going to just shove in here. I'm going to have an explored list so I keep track of what's been explored as we run this. So we do the next step. Of course, we're going to pop the A to B off of the, let's take a find step, and we're going to pop B off. B is not yet on the explored list, so we'll add it. I suppose explored is a set, so we will add it. I hope you can see this and it's big enough. Maybe we'll make it slightly bigger. You should be able to see that. All right, so so A and B are now on my explored list because I popped this off. I find the neighbors of B. It's C. I put it back on. Again, the F value of the ABC path, which is the heuristic 0 plus the 1 and 1, is shorter than the F value for A to D, just because D has that huge heuristic. So we keep going. So let's take another step. We're going to take C off of the frontier. It hasn't been visited yet, so we'll add it to our explored list, right? This is explored. And we'll keep going. So we'll take a find step and we'll put that back on. And still the F value of this longer path to get to E is at the front of the queue, right? So we will take a find step, pull that off. We will add E to our explored list and find E's neighbor and put it back on. And now, because of this giant 4 here, this path is suddenly longer. That's fine. So now it's at the back. Let's keep going. We will take A to D off of the frontier, and now we will add D to our set, right? And we will find D's neighbors, which is just E, so we will add that back onto the frontier. Oh, okay, so this algorithm seems to prune it before it adds it to the frontier. In our algorithm, we would have added it to the frontier, and then the next step would have been we would have taken it off the frontier, and because ADE would be next, and we would take it off and say, oops, since E is already in explored, we can prune it. So this algorithm is pruning it a little bit prematurely, but that's okay. The important thing to see here is that the ADE path got pruned with our algorithm too, which means that we're stuck, right? We can't, sorry, not we're stuck, but we have to use this A, B, C, E, F path. So if I just keep stepping along, take another find step, we'll take F off, this path off, so F gets added to explored, and we take a find step and we put that back on, and we take a find step, and we've got our goal, so we're good. But if you look at the cost of this path is costing us 1, 2, 3, and 7, 8, 9, 10. So this path is costing us 10 when in fact we could have had a path of 9. So that's a problem because this is not an admissible, it's an admissible heuristic, but not consistent.